Hi guys,
Not yet. I
okay.
tell you in a second.
Mute your WhatsApp.
Not yet. Okay, go.
Is your WhatsApp muted?
Mm,
Hi guys, thank you for joining. This is Essence of Medicine. Hi guys, thank you for joining. This is Essence of Science, and today we are talking about stars. I'm Amanda Armagast.
I'm Jimmy.
and I'm Dr. Abbasi for Essence. Stars. It is one of the first thing humanity discovered is that big shining thing in the sky. That without that, there is no life. If there's no light, it's cold. If there is no light, plants cannot grow. And I don't believe anybody need explanation uh, beyond that. That the observation speak for itself. That is a sign of life. And but Jimmy, I was asking you, what is the sign of the sun in Chinese, and does it have any additional meaning?
Yeah, for the star is built up by a character of sun on the top, and the bottom is the symbol of birth.
Birth,
Yeah, birth.
birth,
Yeah,
life.
life. Yeah, life, birth.
Makes
Yeah,
so sense. Makes so
yeah.
sense.
So sun and birth. Yes.
Yeah.
So
Um,
like you said, it gives birth to lives. And
Yeah. Um, did you ever, when you were little, just wonder what that thing up there is? Did you ever wonder?
not really, but I know they looks beautiful. I remember watching them with my family when I was
Okay.
small, and since
Okay.
they're amazing. Yeah.
Yeah. Now, what about you, Amanda? When you were little and so on, I know your interest might be a little different than some other people, but did you ever wonder
Well, you
that?
know I'm kind of an airy fairy being. So
Uh-huh.
of course I've always wondered about the sun and like looked at the sun, and when I was younger, I used to be one of the kids who would wish on the first star that I saw in the sky. So I would pay attention kind of like while the sun was setting and try and figure out which one is the first star that I see. And I remember as a kid staring up at the sky a lot and watching the stars and seeing them twinkling, and I thought that
uh,
that was the coolest thing. But also I've had a really deep meditative experience with the sun. One time I meditated for probably like 3 hours staring at the sun until I felt like I transcended to the sun. And that was a really eye-opening experience for me because I was able to really have a deep connection, I felt like, with the sun and with the way the sun creates life, nurtures life, keeps us warm, keeps us comfortable, but also can be very violent to us.
Yeah.
Because if even if you love the sun and you're so close to the sun, you need to be protected from it.
Yeah. Well, when do you think we understood those little dots in the night are the same as the big sun that we see at day? When do you think we even noted or assumed that is the same?
I think a long time ago, close to when
Like what?
Jesus was walking on earth, I
No,
would
no,
guess.
no, 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 no. You're very, very off.
When people are sailing in the sea, that time when
No.
they start to look at the skies.
Okay, on 17th of February 1600, they burned Giordano Bruno, a monk, on the stake because he said those little dots in the sky are whole new worlds and same as our sun. And they may have as well planet, and they may as well have people like us on those planets. And by the way, Earth is not flat, and we are the sun, even though it appears to us that the sun is turning around our earth, in truth, it is not the case, because we are turning around the sun. On February 17, 1600, he was burned at the stake because he said that, because that was considered a heresy. Would you have thought that?
Mm-mm.
No? So,
Actually, yeah, I would have thought that because any person who's ever pretty much any person that I've heard of who's come across or like gone against status quo or tried to introduce a new idea is philosophically burned at the stake. So I'm not super surprised about that, to be honest.
are you talking about me?
You can take it how you want it.
See that every stage we have a base of knowledge, and 95% of the people buy into that. And even though, like, when you are just outside right now, you will see sun moving in the sky. That is natural to believe that that thing is moving in the sky. But you need a lot more dedication and understanding, looking at more things before you come up with the understanding of a model that explain things. Like, it's not a question. Yes, sun moves in the sky, but why does moon move so slowly? Or why are some stars in the sky that go sometimes one direction, sometimes the other direction? Do you know what I'm talking about?
No.
No? Jimmy, do you understand what I'm talking about?
Like they're on the sky, but they're not always moving in the same way, like every day.
Yes,
Is that
yes.
what you
No,
mean?
yes. Let me tell you something. It was a time people did not have computers, TikTok, social media, TV, and something. When it was dark, you would sit out there and you would look at the skies. That was your hobby. That was the thing. And I'm sure you have seen people, or you know that people look at the clouds, and in clouds we see shapes, right? Because
Mhm.
our brain is made to make sense of everything, and we see a dog or a rabbit in the clouds and so on. In the same way, in the night, we had lots of time, we have nothing else to do, and we look at the sky, we see some stars more prominent, and in our mind, we make them like a figure or something.
Yeah, my favorite constellation is Orion. I love that
Orion.
one. And when I let my dog out for the first time that the stars are out, he's in the fall or fall/winter, he's always in the same little spot. And then when I let my dog out before I go to bed, he's in a different spot. And I've been noticing that actually a lot lately because I've been kind of paying attention to him.
Now, all those constellations have together is that in our view, they appear like a shape. But
Mhm.
many of those stars in the three-dimensional geometry of the space, they are far, far away from each other. Meaning that it is like I'm looking at you and the background, and you are in same line, and the microphone, you and background are in the same line. But in truth, you are not in the same plane. Some of these stars, there are hundreds of thousands of light year away from each other. Now it just happens some of them are bigger, they have more light, so they appear to have similar, like light coming to us from them, and we consider them like a constellation. So what I'm trying to tell you, we understood there are these stars in the sky, and for a long time we had no idea, and it was back and forth about that. Are they source of light? Are there, like our dead ancestors? Are they fable thing? Are there holes in the dome of the sky and so on? And something is beyond them. But with little and little, we notice that um, they have the same characteristic of the light that sun is giving to us. What that means, everything that glows has a spectral of light, different light. Now, not long ago, like in 16, 17, no, not 16, in 17, 1800, once we could, after, as a matter of fact, after Isaac Newton could put a prism on the light and dissect the spectral lines of the light, then we could understand the light that comes from the stars and the light that comes from the sun have the same composition. Obviously, sun is much stronger, but it has the same damn composition. So they must be the same thing. You know, when Isaac Newton did that kind of prism experiment and so on, it was in 1700 something. So we have suspected, and we burned one of the first person who said that on the stake, but we have evidence for just few hundred years that sun is a star exactly like the atom. As a matter of fact, sun is not even a special star. It's just the middle of the road, the boring mid-size star.
Just closer
But,
to us. That is,
yeah, it's
that's
just
why
so
it's
much
bigger.
closer to us. How close is sun to us?
Like 8 light minutes, right?
8 minutes and 21 seconds, about 8 minutes and 21 seconds. What that means is that you can, the speed of light, right? About 300,000 kilometers a second. You can just multiply that. So it's about a billion mile away from us. There's, I'm sorry, 100 billion,
100 million.
100 million miles away from us. 100 million miles. Now, this is something as well I was very surprised. Oh, how many suns would fit between sun and earth?
Wow.
Amanda, do you want to guess? You're usually good at guessing this stuff.
I am a good guesser. I always have been.
Yeah.
Okay, so
How
wait.
many sun can we put between sun and earth? Sun to sun, sun to sun. How many? Jimmy's cheating.
No, I'm not. I really am guessing.
I'm gonna
I'm
okay,
guessing
hold on.
0.
Is it more or less than 12?
I'm guessing less than 1.
So you mean the sun, you can fit only one more sun between sun and earth?
That's my guess.
Okay, and you say 12, Amanda.
Yeah, that's
It
my
is
lucky
100.
number.
100.
100.
100. Okay.
Yeah. It's 100 because you remember we said the diameter of the sun is about a million kilometer about. So, and it's about 100 million between sun and earth, so you can fit 100. I would have thought it is in millions and billions and thousands. I would have thought it's much, much farther. But sun is ginormous. Okay? As a matter of fact, 99% of the mass of the entire solar system, or 98, I believe, is in sun. And everything else in the solar system is about 1 or 2%. And from that 1 or 2%, 90% is Jupiter. So this is, you see, understand there that why in 1600, 1700, where you have a human-centric view that everything is made for us. The whole thing is made for us. And then somebody comes and says, we are so insignificant. Not only the sun is not turning around us, but our sun is as well not even that important. It's a middle, the size, mid-size, it's a Toyota Camry at best.
Well, you know what? Humans have always had a really hard time grasping their insignificance.
Yeah.
Even now, we realize how insignificant we are, or actually, we're significant in the sense of the damage that we're doing, but we're so insignificant in the scape of of the universe, and we still have such a hard time grasping that we want to be, now we're better than animals. We're like, it's always this, it's always that. But why, when I look at the sky and I'm looking at the stars and I see the brightest star in the sky, is it usually a planet? Why do the planets look like stars to us?
Okay, well, that is exactly the long path I wanted to get there.
So now we're there.
We were sitting on the campfire, looking at the star, and we were observing them. We were good at reading them. We knew them because that was the only thing we could do. Okay? Every child could point to a constellation. Every person would see some of those stars, sometimes recognize them, and see sometimes they move this way, sometimes they move that way. And
And sometimes they're not there at all.
and we couldn't wrap our head around that. Why this five thing moves sometimes one way, other way, but everything else moves the same way. Do you know what those 5 things are?
Yep, asteroids,
No. We
planets.
cannot see asteroids. They're too small for us, but they're the main 5 planets: Mercury, Venus.
What about shooting stars? What are they then? What are shooting stars?
Shooting stars, they come and go, but I'm talking about truly things that look like star in the sky.
But am I wrong that shooting stars are asteroids, or what are shooting stars then?
Well, shooting star are asteroids, but
Okay, so we can see them.
well, you are taking me completely somewhere else. I'm talking about in the night, you look at the stars, something that look like the stars. And for people who are familiar with that, they know, is this the same star? Like one of them is a little reddish, one of them is different color and so on. But contrary to other stars, they don't always move the same direction. Sometimes in the sky, every day move to right, sometimes they move to the left. And they want to call them the wanderer, the 5 wanderer. Those 5 wanderers are the 5 planets that we know planet means the wanderer. So there are Mercury, Venus, what else? Mars. What are the other 2 wanderers?
Jupiter,
Jupiter?
Saturn.
Yeah, those are the things that you can see with the naked eye, actually. So
Are they just the rest of the planet in the solar system except from Earth and Sun?
Well, there's 8 planets in the solar system.
Okay.
well,
There used to be 9.
Yeah, but we couldn't see all of them. We could see these 5 we could recognize with naked eye, and we would see them. They look like the star because the light of the sun goes to them, reflect back to us. And then because we are all going around the orbit of the sun, we would, depending on if they were on our side or the other side, we would see them moving right and left, whereas everything else every day move in one direction. Those 5 sometimes move to the right, sometimes move to the left, and we couldn't explain that. And then Copernicus came and created a model that would explain that. That was heliocentric or sun-centric models. He was threatened with being burned at the stake for that. But Bruno was long before that. So we had the knowledge, we have the intellect. We just have to fight the status quo, the established knowledge. Like, no, this is the way it is. Okay? It is like no different than people saying the spine surgery should take 8 hours. If you are less than 8 hours, it's something wrong with you. It's not like you have a new knowledge or something. And that was then, and still science, unfortunately, is still that dogmas still exist. Now let's talk about the sun. Finally, we knew sun is nothing but just another star. But we still couldn't explain all the heat, obviously from the spectral line. Then we figured out that what temperature sun should be. Because there is actually a formula that can tell you, depending on light temperature, every light has a temperature, what temperature that original thing is that's sending that light to us. That happened actually first in 19th century, but eventually it was a good question. We know what the temperature of sun, but where's that energy is coming from? As a matter of fact, somebody calculated that is maybe lots of wood is burning on sun. No, this is serious. This was our understanding that somebody has a pile of wood burning there, and that's where it's coming from. But they calculated that if the entire mass of sun was wood and it would burn, how long do you think it would take for the entire mass of the sun to burn? How long would that take?
If it's just wood,
It was if you had the mass of the sun and you had enough oxygen, okay, I just assume that. How long would it take for all of that to burn?
I
Well,
would
I
guess
mean,
short.
is it solid wood or is it like piles of twigs? You know what
I
I
don't
mean?
believe they really distinguish
Like,
between
because
that.
I
that's a
mean,
huge difference.
just I think just a week or so, it's just gonna burn out. That's my guess.
I would
So,
guess a couple months, less than a year.
100,000 years.
100.
10,000 years. 10,000 years.
So
10,000
solid wood
okay.
then is what they were
If it was
thinking.
solid wood and it would burn continuously, it would burn for 10,000 years. So at that point, we already know that there are things that are older than 10,000 years. So that was mute. When do you think we understood that what really makes the sun glow?
What really makes the sun glow?
Yes, well, no, number one, both of you. Do you know what makes the sun glow? And number two, when do you think we figured out what makes the sun glow? Is a woman, is a woman in play in this understanding? Very famous woman. But go ahead.
Isn't it gas? Isn't the sun made up of gas?
Yeah, it is. What gas?
Oh, I do not know my gases.
You do not. I love the way you say that. I do not know my gases. So, Jimmy, what makes sun glow? Nuclear fission, right?
Nuclear, yeah.
So, what is
Oh,
happening
yeah.
inside of the sun?
So
Inside
it's
of the
always
sun?
the nuclear reaction is always happening there.
Yes, yes. So now number two question was, when did we figure it out?
I think like the late 1800s.
Exactly. That was actually the Marie Curie.
Oh,
figured out-
I had that in the back of my head, but I didn't want to sound dumb.
Yeah.
I know you
So
love her.
Marie Curie figured out there is some material, he called it radioactive, that they get warm. The thing itself get warm. And then he noticed if you put it on the photographic plate, it's literally it gives something that make the photo as if you would take a picture, meaning like something like a light hits it. Now, it took a lot longer to understand that what she discovered is nuclear, literally uranium falling apart, whereas in sun, what she discovered is one big atom becoming two atom, but in sun is just the opposite. Two atom become one. Fission and fusion. In sun, we have nuclear fusion. Marie Curie discovered nuclear fission, meaning one molecule, one atom become multiple atom. Either way, certain part of the energy, like in an atom bomb, turn from matter to energy. Like, most of the universe is okay, this is beautiful. I love that. Our universe, entire universe, what is it made of?
Thing.
Carbon.
Yes,
Are you
carbon.
wanting us to list out what
No,
it's
no, but
made out of?
yeah, list down.
Carbon, obviously,
What percentage of the universe do you think is carbon?
like 30.
30, okay. Jimmy, what do you think? What percent of the universe is carbon?
15%.
15%. So
Okay.
70% of the observable universe, what we see in the universe, is made of dark energy. We have no idea what it is.
Okay, so that is dark energy. So since we don't know, we say it's a combination of dark energy.
Yes.
Okay.
Another 25% of the universe is made of dark matter. We have no idea what it is. Everything, the matter we know it, is only 5% of the universe.
So wait, okay, sorry. So what I'm understanding is that there's a lot of the universe that and so this is going to be long-winded. Please let me say all of it. There's a lot of the universe that we don't understand what that is. Is that correct? So what
Well,
you're saying is we don't know the element that it's made up of?
so the universe is behaving in a way that there must be so much energy and so much matter in it.
So is that like we don't know the element that it's
We
made
don't
up
know
of?
exactly what it is, but we see the effect of it. We see universe is behaving with the gravity and how fast things are moving, that so much energy and so much matter must be in it. But 70% of that is a energy, kind of energy that we don't know what it is.
So, because I have a theory that you've told me before is incorrect, that we haven't discovered all of the elements on the periodic table. I don't think that we've discovered all of them. So, does that mean that there is the possibility that some of this matter, considering it's over 50%, it's 70%, that we don't know what it is, it's dark matter, we're not sure, could be an element that we haven't discovered yet?
No, it cannot be that because even if it's a regular matter, we have some evidence of that because they radiate, no matter what they are, some kind of energy that we can measure. So literally 70% of everything that makes up the universe is a kind of energy that we cannot measure, we cannot interact, we have no idea what it is. Another 25% of that is what we call dark matter. Energy pushes out, dark matter, gravity pushes in, and we don't know what it is, but it must be there, and it's not something that we can really see or interact with. Everything that is like you and I makes only 5% of the universe. Now, that imagine that 5% of the observable universe, okay, is made out of energy and matter and so on and so forth and so forth. But forget about the energy. Let's talk about the matter, like atoms and things that makes you and I. And we have the periodic table, right? We used to have 104. Now we have some other element. Many of them are unstable, but general matter like hydrogen, helium, carbon, iron, and so on and so forth. So now that we're talking about a small fraction of the observable universe,
Wait, sorry. I'm still thinking about that. So there used to be 104 and now there's how many?
there are not now I think are 109 or
Okay,
112.
so it is
Yeah.
possible that there's some that we don't know about, even though they say it's not. You can burn me at the stake, but it is possible then. But continue.
Okay, if you would have gone few hundred years back, you would be definitely be burned at stake, Amanda. You
And
know
that's
that.
fine because I'll come back and they can burn me again because I'm not gonna stop.
No, no, but that is not how it works, though. Those are unstable elements. After certain size of the atom become unstable. We built them, but some of them survive only a millisecond or nanosecond, some of them. So, but either way, we have a periodic table, all the observable universe that it makes sense to us. Jimmy, what do you think? What percentage of that is like hydrogen, helium, and then lithium, calcium, carbon, iron, and so on and so forth? What do you think? Let's
In
start with let's
like
start with the two major ones, helium and hydrogen. What percentage of the universe is helium? What percentage of universe is hydrogen from observable matter?
Okay,
f-
so
one
that's the
out, and this is like,
5%, right? Out
but
of that 5%.
No,
are you
but no,
talking about 100% of the 30%?
no, I'm talking about 100% of the matter in the universe. Not, we talked about that. That's a small fraction of everything that exists. Now, let's say from what the periodic table in the universe that we see, everything that is that small percentages that is not dark matter, is not dark energy, is not regular energy, everything that's matter. What percentage is hydrogen, helium, and so on and so forth?
This time I'll guess 80%.
80% is what?
Is the hydrogen and the other one
Helium?
helium, yeah.
80% is hydrogen and helium. Amanda, what do you think?
I think like 20%, I think like 10% is helium and more like like maybe 60% is hydrogen, because I'm also thinking hydrogen is in the water and stuff like that. Or are you talking about solo hydrogen, not
Solo
H2O?
hydrogen, whatever. I mean, hydrogen as general.
Okay, I think hydrogen might be like close to 60, 70, and I think helium might be close to like 20.
Yeah, as a matter of fact, you both are right in a way. 80% is hydrogen, or 75 to 80% is hydrogen. The other 20 to 25% is helium. Everything else is negligible, like absolutely like 0, 0, 0, lots of zeros and so on. Everything else, like
Including oxygen.
your oxygen, everything
Okay.
else is unfathomably low percentage. Rocks, trees, and so on and so forth. If you consider the volume of the universe, is you can just, rule of thumb, 80% hydrogen, 20% helium. And everything else, so you are rare. Whatever you are made of, Amanda, that is so rare in the universe. All your carbons, calciums,
Thank you.
oxygen that makes the water in you and so on, they're negligible. So, but why? Why is that way? I'm not going to go all the way to the Big Bang and expansion and so on, but it seems that at certain point there was a lots of energy. Some of that energy became matter. What is the best matter, easiest matter out there?
Well, we're all made up of stardust.
Well, that we come back in few seconds, but it's true, but it's not. We are not there yet. So first, the whole universe is made of exotic matter, exotic energy. Not exotic dancer, exotic matter and energy. But then it cools down and it produces the two easiest atom that exist, hydrogen and helium. And that's all what's there. There are some rare things there, but mostly hydrogen and helium. And the composition of the universe is still the same as 13 billion years ago, mostly hydrogen, a little helium. But then gravity comes to work. Gravity comes and bring all that gas, hydrogen. Now you can know your gases. Hydrogen comes together and the gravity compacted more and more and more to a point that in the core of our star, the temperature is 100 million degree. Okay? That temperature and that pressure makes 2 or 4 hydrogen atom come together, overcome that positive. They have obviously hydrogen atoms are positively charged, they repel each other, but the pressure becomes so much that they get together, 4 of them, and they make one helium. Now one helium is a little tiny bit, like a small fraction of a percentage lighter than 4 hydrogen atom. That different in mass becomes energy. And now You have a source of energy in the core of the sun. Now, it's important because that energy is pushing out, whereas the gravity of sun is pushing back in. Now, let's talk about that. So we talked about the source of the energy of the sun is in the core of the sun with 100 million degree temperature, and it produces this energy in form of photons. Photons are packet of light and energy. Like when you go under the sun, you feel the warmth. Those are the photons from the sun that hit your arm. And Amanda, you told me, how long does it take for that photon from the sun to hit your arm again?
Pretty much 8.8
Eight-
minutes, 20 seconds.
Yeah, 8 minutes, 20 seconds. But those photons are not produced on the surface of the sun. They are produced in the core of the sun. Now, tell me, how long does it take from the core of the sun for that photon to come out to the surface of the sun and then take 8 minutes to come to you? What do you think from the core of the sun to the surface of the sun? How long does that take?
I think that can't like pretty much 108 108 Earths fit in the sun. So that means it would have to be like 52. I don't know.
Jimmy, what do you think? That you understand now that with the pressure and temperature in the core of the sun, four hydrogen come together, they become a helium.
I
It's a
mean, I think the energy decrease as it goes, so I suppose.
No, a photon has the same energy. A photon is a package of light or energy. That photon keep its energy.
Okay, keep
Either
the
get
energy.
absorbed and so on, but that photon has to come from the core of the sun to the surface of the sun before it comes to us, right?
Can I say my guess? I think it's 12 minutes.
12 minutes. Okay, what do you think?
Uh,
No, it takes more to go from the core of the sun to the surface than from the sun to us. Is that what
No,
you're
I
saying?
thought you were saying how long does it take to get from the center of the sun to us?
No. From the how long does it?
Okay, then mine is 4 minutes.
I'm sorry. Can you repeat that? Amanda?
4 minutes is my
4 minutes.
answer.
4 minutes. Okay. Jimmy, how long does it take to go from the core of the sun to the surface of the sun?
10 seconds.
10 seconds?
Uh,
Okay. What about 300,000 years?
300,000 years.
300,000 years. That is what it takes to go for that photon that was produced in the core of the sun to get to the surface of the sun. How
So
does that make sense?
it means the energy we're using right now is produced
Yes. Isn't that amazing?
so far back.
Energy that you receive from the sun. But do you mind to explain to me how does that even make sense? How does it make sense? Because it is the sun across the sun is 1,000,000 kilometers or mile, and it has to go from the core, meaning half of that. It has to go from half of that to the surface. Why does it take so long?
The mass of the sun is too much.
Well, Amanda, do you remember when we were in India and we couldn't walk 30 minutes, 30 feet without bumping into people, saying hello, and then that slows us down. It would take us literally 45 minutes to walk something that would be, if you walk straight, it would take you like 10 seconds.
Yeah.
Same in the sun. It's so dense that photon, it doesn't go straight out. There's no way it's straight out. It hits an atom, it gets absorbed, it gets emitted. Then it hits another atom, get re-emitted. And he does it 300,000 years before it reaches the surface of the sun, before then it can escape from the sun. So right now, if you go out there, that energy that you absorb was emitted 300,000 years ago.
Mhm.
Now, okay, well, this explains how it produces the energy, but as well it explains why we have helium in the universe. The most of the helium in the universe was produced in the initial Big Bang. A little get produced. Now, you said a little far back, we are stardust. What did you mean by that, Amanda?
Like when the stars die
Mhm.
and they disappear, they dissolve, all of their energies kind of spread away, then that matter becomes humans.
Yeah. How do star dies though?
Like old age.
Like the
Like me, old
like the
age,
the
not the
nuclear
beard, black, the
I
black hair
think there's
become
too much
white.
energy. I think like maybe there's not enough energy or too much energy. That's
like
my
it
guess.
run out of fuel, so the reaction stop and it dies down.
What do you mean by they run out of fuel? What do you mean by that?
Uh, because they're burning, there must be
Burning
some
hydrogen, yes,
yeah.
yes.
So
Burning hydrogen. When the amount of the hydrogen become low, then um, they don't produce too much energy. What happens is that literally the gravity becomes stronger, meaning
gravity.
the gravity becomes stronger because see the star the fission the fusion where the two four hydrogen become one helium produce energy pushes out, gravity is pushing down. When they are running out of um, hydrogen, gravity starts winning, meaning the temperature and pressure goes up. When the temperature and pressure goes up, not only hydrogen fuse together, but as well helium fuse together. And then you have lithium and carbon. Okay? And then that happens again when they run low on helium, then or other thing, then two carbon come together. Two carbon come together. It's a little more complex than that, but for practical purpose, so lots of hydrogen, lots of energy pushed out, but the pressure is not enough to fuse helium together. But then when low on hydrogen, gravity start winning more pressure, more temperature, helium fuses to carbon. And then next step, carbon become oxygen. Then oxygen becomes something else. And this goes up all the way to iron. There's a problem with iron. Iron, when two molecule makes iron, it doesn't produce energy. It actually absorbs energy. So iron is the death of the star. But iron is not even 1/4 in the periodic table. So, but iron is the death of a star, meaning that there's not enough energy to push the gravity out. When star get to that point that producing iron, in a millisecond, gravity wins. When gravity wins is no different than when you throw a huge, very rapid baseball at the surface. The energy of everything falling together is ginormous. In a process that it's called a supernova, all of a sudden, entire mass of the star falls together and then explodes. In that explosion, there are lots of other material produced that makes you and I, Amanda. That's how we are stardust. And it's a little more complex, but in that moment, when that happens, there are lots of neutrons. And then these neutrons, they just hit every possible atom in that cloud. And in the process that called neutron capturing, this big molecule exists and then they break down into lots of everything above iron, including gold, silver, and so on and so forth. Most of the molecule in your body is literally made of material that happens only when a star dies. So a dying star is what makes the life possible because all the way up to iron, that's not enough for life. And by the way, if that was enough for the life and the star wouldn't explode, all those material wouldn't get out of the star, so there is no way life could exist. So
So the
it-
fraction of these things fly to the Earth or fly.
oh, let's talk about that. How did our sun come to be 4.5?
Is this is the sun a different podcast topic than stars?
Well, sun is a star. That is how
I'm
sun
just thinking
is a
because don't you have another one coming up as well? Another podcast that we need to watch out the time for?
Yeah, it is what time is the other podcast? I thought it's at 3 o'clock.
No, it was at 2:30 and I
Okay.
don't know if you changed the
Yeah, it is
time.
2:30. It's 2:30. Okay,
2:30.
so let's get to that. Amanda is trying to keep us on time track. Okay, so
And on topic because our topic is stars and I think we've mostly talked about the sun.
well, okay, well, sun is a star, Mrs. Gremlin. Sun is a star. That's how stars exist. Okay, so the exploding star, this supernova, spread all the material out of the star, any star, including sun. And depending though on the weight, how much mass a star has, stars die in different way though. Okay, so but definitely our solar system, the reason why we exist is based on a star bigger than the sun went supernova and spread all the things that, including iron that we have our buildings of, including calcium, including rocks and so on, that comes from a supernova. But then the mass of the sun is much, much smaller than to go supernova. What that means is that most likely either it was another sun close by, meaning that our sun was a kind of binary system, or it was much, much bigger when supernova exploded and the remaining of that became our current sun. Either way, that is why we exist, because those materials that were made in the core of the sun and in supernova spread out, make the earth and everything else and so on. Now, what's important here is that I'm talking about the stars. If you have bigger stars, their life expectancy is shorter than small stars, because bigger stars produce a lot more pressure inside. All the material burns so much faster. So now let's talk about our star, sun. It's 4.5 billion years. How long do you think, Amanda, our sun will exist?
Longer than us.
No kidding. We have few more minutes, but I want to say about the end of our solar system and end of our star. It's the expected life expectancy. We are halfway through. It's probably our sun will live another 4.5 billion years, which is a long, long time. But we won't live 4.5 billion years, because in about a million year from in about a billion year from now, the sun, the amount of the hydrogen in sun will literally be reduced, and then it start burning helium. Helium is hotter. Hotter helium pushes the outer part of the sun out. So our sun will become something that we call red giant, meaning the hot gases from the sun will expand and will engulf Mercury, Venus, and Earth. That happens far, far in the future, but that process starts in about a billion years. So sun becomes so hot that the life on Earth will become impossible. So everybody you are listening, you have a billion year. That's all you got. As a matter of fact, most likely 700 million years. That's all what we got. Doesn't it make you a little depressed?
Not
Yeah,
at
I'm
all. Not
depressed
1 bit.
about that.
Huh?
I'm depressed about that. Yeah.
Yes, in 700 million years, everything we know, all the suffering, all the culture, all the music, everything we got become irrelevant. We are wiped out.
Yeah.
That's one way you can see that. But in the other way, maybe in that long, everything we know is just last few hundred years. In that long time frame, if we haven't killed ourselves, we have figured out a way to do lots of things. So I'm not depressed. I used to be very much depressed about that, Jimmy, but I'm not anymore. So it is almost 2 o'clock, Amanda.
I have a question.
Yeah.
So you know how humans are destroying the earth pretty rapidly? Is there any like and so you know the earth is like water and land, and
Okay.
the humans are really destroying things really fast when it
Okay.
comes to nature and the balance equilibrium of the planet. Is there any possibility that the damage that the humans can do to the earth would speed up anything like relating to the sun or any other planets?
No,
Okay, that's good.
no. We are
We're
if
too
you
small
consider
to
the
affect
amount
it.
of the mass and the energy is going out there, we are unfortunately, well, with everything we do, we can cause a lots of damage to the climate and the ecosystem and so on and so forth. But we are insignificant to cause.
To the
Like,
universe, but not to the planet.
well, we can change the ecosystem of the planet. We can do like a greenhouse effect and speed up that processes and so on. But sun, moon, the rest of the solar system wouldn't even care about that.
Yeah, just Earth.
Insignificant. Yeah, just Earth. We can
And then
make,
maybe
we
Mars.
can make Earth uninhabitable long before the sun's increase in energy and temperature would make Earth uninhabitable. So,
So thank you guys for joining. This was Essence of Science, and we talked about the sun. I'm Amanda Armagost.
I'm Jimmy.
and I'm Dr. Abbasi for Essence. And think about that you're enjoying the sun rays that were produced 300,000 years ago.
Have a safe weekend.